In this video, we're going to continue our discussion of Maclaurin and Taylor series. Find the first three non-zero terms in the Maclaurin series for f of x is equal to e to the power of 2x times sine x. We can certainly apply the Taylor series formula directly by differentiating f of x many times and evaluating derivatives at x equals 0. But since we know the Maclaurin series of e to the power of 2x and the Maclaurin series of sine x, we can simply multiply them and collect the first three terms. So let's start with the Maclaurin series of e to the power of x. E to the power of x is equal to 1 plus x divided by 1 factorial plus x squared divided by 2 factorial plus x cubed divided by 3 factorial and so on. Now we need the Maclaurin series of e to the power of 2x. So let's replace x by 2x. E to the power of 2x is equal to 1 plus 2x divided by 1 factorial plus 2x all squared divided by 2 factorial plus 2x all cubed divided by 3 factorial and so on. Now let's look at the Maclaurin series of sine x. Sine x is equal to x minus x cubed divided by 3 factorial plus x to the 5 divided by 5 factorial minus x to the power of 7 divided by 7 factorial and so on. Now it's worth noting that we have an infinite polynomial representation of e to the power of 2x. That's what the Maclaurin series is. It's an infinite polynomial. We also have an infinite polynomial representation of sine x. So we're just going to multiply out these two infinite polynomials and collect like terms in the order of increasing powers of x, because we only need the first three terms. So e to the power of 2x times sine x is equal to 1 plus 2x divided by 1 factorial plus 2 squared x squared divided by 2 factorial plus 2 to the power of 3 x cubed divided by 3 factorial and so on. Multiply this by the Maclaurin series of sine x. X minus x cubed divided by 3 factorial plus x to the power of 5 divided by 5 factorial and so on. Alright, so now let's do the multiplication. We're going to FOIL out these two polynomials. So let's start with the first term 1 and multiply it by every term in the second expression. So we're going to get 1 times x is x minus x cubed divided by 3 factorial plus x to the power of 5 divided by 5 factorial. Now the second term, so 2x times x, that's going to give us 2x squared divided by 1 factorial minus 2x to the 4th divided by 3 factorial plus 2x to the 6th divided by 5 factorial plus 2 squared x cubed divided by 2 factorial minus 2 squared x to the power of 5 divided by 2 factorial times 3 factorial plus 2 squared x to the power of 7 divided by 2 factorial times 5 factorial plus 2 cubed times, so we're looking at this term, multiply it by x and just FOIL it out. Then multiply by x cubed over 3 factorial and multiply by x to the 5 divided by 5 factorial. We get 2 cubed x to the power of 4 divided by 3 factorial minus 2 cubed x to the power of 6 divided by 3 factorial times 3 factorial. The algebra is very tedious and it's very easy to make mistakes, so you certainly don't want to leave any terms behind. Plus 2 cubed x to the 8 divided by 3 factorial 5 factorial. Now, we certainly have more terms than we need, but this is we just want to be on a safe side of not leaving any powers of x behind. So let's look at the powers of x. So we only have this one. This is the only term that involves x. Now, the next highest power is x squared. So that's this term, 2x squared divided by 1 factorial, and we don't have any other term that involves x squared. Now let's look at powers of x cubed. So powers of x cubed, we have this term here, and we have this term. So there it is. And now that we have color-coded it, let's write down the first three, let's collect the first three terms in order of increasing powers of x. So what we have is e to the power of 2x times sine x is equal to x plus 2x squared plus negative 1 divided by 3 factorial plus 2 squared divided by 2 factorial times x cubed, and so on. But we only need the first three terms. Let's simplify these coefficients. We have negative 1 over 6 plus 2. That works out to 11 divided by 6. So we get x plus 2x squared plus 11 divided by 6, x to the power of 3, and so on. So this is the Maclaurin series representation, the first three terms of the Maclaurin series representation of e to the 2x times sine x. So the purpose of this video was to show that not only can we add Maclaurin series of two functions, subtract them, but we can also multiply Maclaurin series of two functions, and you can also divide by doing long division the Maclaurin series of two functions. In this case, we're looking at multiplication of the Maclaurin series of e to the 2x times sine x. All right, thanks.